Welcome student. We are going to discuss a general chemistry SAM 1 FY CH1501 and unit 3 A part atomic structure and wave mechanics, weightage 7 marks by Dr. Devanga Pandya, Department of Chemistry, St. Xavier's College Autonomous, Ahmedabad. The syllabus points for this unit 3A atomic structure and wave mechanics are the idea of de Broglie's matter wave, dual nature and duality, a derivation of de Broglie's equation for the wavelength of electron, impotence of de Broglie's dual nature of the matter wave. This much we need to discuss into de Broglie's matter wave or concept duality. Uncertainty principle of Heisenberg and its experimental verification we need to discuss here. Then Schrodinger wave equation and derivation of Schrodinger wave equation that we need to discuss in this point. Normalized and orthogonal wave, what are the conditions for normalization and what are the condition of orthogonal wave, the numericals related to normalization and orthogonality we need to discuss over here. At the same time, we need to discuss the condition associated with the well-behaved wave function we need to discuss in this point. Quantum mechanics and quantum numbers and their significance we need to discuss over here. And then radial and angular wave functions, and that gives a little bit information regarding the atomic structure and the wave nature of the electron rotating in the outer orbital of the extranucleus. So that we need to discuss in this point. Shape of s, p and d orbitals and their characteristic we need to discuss over here. And with that we need to discuss the variation of orbital energies with atomic number and energy level diagram. So this much is there. As far as reference books for this unit 3A 7 marks weightage is concerned, if you prefer foreign authors, Concise Inorganic Chemistry by J.D. Lee is there, Inorganic Chemistry by James E. Hohey, Inorganic Chemistry by Shriver and Atkins. These are the three good book as far as basic inorganic chemistry is concerned. And foreign authors, if you prefer, if you want to learn from Indian author, in Inorganic Chemistry by Satya Prakash Toli, R.D. Madan, Aschand publication is a good book. Volume 1 you need to go for. Inorganic Chemistry by P.L. Soni and R.D. Madan, that is also a good book, but some typological mistake that you need to rectify from this book. The atomic structures information can be obtained from these two books. That much is enough for the atomic structure. As far as wave mechanics is concerned, Quantum Chemistry by A.K. Chandra and R.K. Prasad if you prefer Indian author, and if you prefer foreign author, Quantum Chemistry by Levin is the good book. So these are the reference books for this unit 3A atomic structure and wave mechanics. Now, what is chemistry? How you understand what is chemistry or what you define? When you ask this question to even a chemistry scholar or a master's degree student, you found different definition. They define chemistry as everyday science, day-to-day science, or they define chemistry as linking subject to physical world with life science. They define chemistry saying that some chemical compound participate in reaction and gives new product. So different definitions come out when you ask regarding this. But if you will ask me what is chemistry, I will give you an example of a Nobel laureates and you come to know how to define word chemistry. If you know that in 2009 one Indian scientist get Nobel Prize, Indian origin but US scientist get Nobel Prize. It is Venkat Raman. That fellow is by birth Indian, is from Tamil Nadu and brought up at Gujarat, Baroda. His parents, both mother and father, have started biochemistry department in MS University of Baroda, and his entire education, maybe up to master degree, done in MS University Baroda. He has done a master degree with physics, uh, and then after he pursued his research work in US, he got the citizenship in US there, and he started doing research work there. He used physics instrument, that is XRD, X-ray diffraction, and he has taken a biological molecule, that is ribosomes, and in ribosome, the ribosome is responsible to generate some proteins which are responsible for human aging, and he has given three-dimensional structure for that protein biochemical molecule. So a man of physics has worked on biological ingredient and gave a structure of a biomolecules and got Nobel Prize for chemistry. So this gives you little idea to define what chemistry is. Until or unless you won't discuss a chemical structure, you cannot define chemistry. And therefore, to define chemistry, five things you need to keep into mind. First, the source and purification of a chemical compound, then physical chemical property, then the structure of the compound, and then its application. When you include all these things, you can define a chemistry. That means chemistry is a subject which define uh, the source, purification, structural information of chemical compound, its physical chemical property, and its application. That subject is considered as chemistry. So chemistry is a branch of science that has been around for a long time. In fact, chemistry is known to date back to as far as the prehistoric times, and due to the amount of time chemistry takes up on the timeline, the science is split into four general chronological categories. The four categories are prehistoric time, beginning of the Christian era, that is black magic, beginning of the Christian era and end of the 17th century, that is alchemy, end of 17th century to mid 19th century, that is a traditional chemistry, and mid 19th century to present modern chemistry. So that way the timeline would be there associated with the subject chemistry. Now how the chemistry word used, how the chemistry word comes into existence. For that we need to go into a little back in the history. The Greek word chemia, Chemeia, chemia first appears in about the 4th century and was used to designate the art of metal working, especially the possible change of base metals into gold and silver. The Arab later prefixed the article al, and alchemy came finally to signify the art of chemistry in general. So chemia was probably derived from the Greek word chemi, which means black. There are three possible reasons for the use of this word. The black soil of the Nile Valley gave the Greek the name chemi for Egypt, where the chemical arts presumably originated. At certain blackening process was frequently mentioned as a preliminary to whitening or yellowing of silver or gold, in the sense of dark or hidden, since the dark, hidden, or divine art was the only name by which this science was known to the ancients. Some hold that the word chemistry had a Chinese origin. It may have been derived from the Hakka term chemia or the Cantonese term chemia, which signify gone astray in search of gold or secret of gold. They are suggested to be the origin of Greek chemia, the French chemie, the German chemia, and the Arabian alchemy. From alchemy to chemistry, alchemists believed that all metals was made of some four elements. Like in our Hindu mythology, five elements are there. The alchemist believed that all metals made of same four elements: earth, air, fire and water. And in Hindu mythology, sky is added into these four, that is Panchatattva, Panchamahabhut, in different arrangements and proportions. In other words, silver was thought to consist of earth, air, fire, and water, as were frogs, bricks, and everything else in the universe. Alchemy consisted of trying to alter the proportions of these elements to make desired substances. According to this idea of matter, every chemical reaction was a kind of transmutation. The transmutation is a change in which one type of matter becomes another. For instance, alchemists believed that lead could be transmuted into gold, or they can believe that mercury can be transmuted into gold. It is now known that transmutation can occur only in a specific circumstances, such as during some type of radioactive decay, etc. So that is the belief of these alchemists, and they have contributed to chemistry. The first book in chemistry is one of the first alchemists to break with centuries of secrecy was German alchemist Andreas Lebesgue during 1940s, probably to 1660s. In 1597, he published what is considered by some to be the first chemistry textbook. This book summarized the knowledge of alchemists in clear language that one could understand. And then after, another fellow, Robert Boyle, has started converting that alchemy into chemistry. So he has narrated many things in his philosophical work by Robert Boyle. So this is the second ever book in chemistry where Robert Boyle has narrated the alchemic practicals into this book. So that way, chemistry study begins. Now, as far as Indian chemistry is considered, or the role of the ancient Indian in the chemistry, India has a very ancient tradition of chemistry. In ancient texts, amazing information is available on metals, ores, their quarries, compounds and alloys. There are also detailed of hundreds of devices used in chemical experiments in Rasayana Shastra, which we call chemistry. There have been many chemists in the past. The creation of some of them you can see here. Vag Bhatt, Rasatana Samoshaya, then Govindacharya, Rasarnava, then Yashodhara, Rasa Prakasha Sudhakara, then Ramachandra Chetanamani, and then Samdev has given Rasendra Chudamani. So they are the contributor in chemistry from ancient India. You can see Nagarjun, Acharya Nagarjun, who has written Rasaratnakar. So this is a book written by Indian chemist Rasa Ratnakar, and it includes so many information regarding chemistry. You can see some poetry prepared by ancient Indians, and this is a fellow who is father of ancient Indian chemistry. His Siddha dreams, and that he has contributed a lot in ancient India for chemistry. You can see one fine example of the alloying, that is this pillar, Ashoka pillar, who after this many time, yet it hasn't any kind of corrosion on it. So that way India also have great contribution in chemistry. Now, history of atomic structure. Our main prerequisite begin from here. The history of atom theories and model, or we can say how evolution take place in atomic structure. And to understand that, we need to start with the work of John Dalton. John Dalton was an English chemist, physicist, and materialist. He is best known for introducing the atomic theory into chemistry, and during his time there is no instrumental facility available, so with pen, paper and brain he has given his atomic model, and you can see here his atomic model is there. When Dalton has given his atomic model, at that time there is no any study done for nuclear chemistry or any kind of subatomic particle, and that is the reason to the smallest matter John Dalton has used a Greek term atomios, means indivisible. So that way he has given the atomic theory in 1803, and he has also given the law of conservation of mass as well. But as already I've said that cosmic science and nuclear chemistry is not flourished that much, so people won't know that even the atom can be divided into subatomic particle like proton, electron, positron, neutron, and even smallest particle like Higgs boson or God particle. So that was the time where this kind of information would not be there, so Dalton has given his theory. Dalton has another contribution. He has done his research into color blindness, and some referred to this theory as Daltonism in his honor. John Dalton was a British chemist, as already I have said, most famous for his contribution to the atomic theory, and that laid the foundation of modern chemistry. Born to the Quaker family of modest means, Dalton started working as a teacher when he was only 12-year old and did most of his education while he taught. He began his scientific career as a materialist, making several important contributions in the field before becoming one of the most important chemists of all time. Moreover, about the life, family, education and work of his great scientist, please read about his autobiography. You come to know more information regarding Dalton's contribution. His atomic model has certainly got some limitation, but still it is not completely ruled out. After Dalton, another scientist who has given his contribution in addressing the atomic structure, that is J. Thomson. He has given his plum pudding model, stating that proton and electron are distributed in atom uniformly. So that was his plum pudding model, J. Thomson. Thomson is created with the discovery of electron, the negatively charged particle in atom. He is known for the Thomson atomic theory. Nobel Prize he got in physics in 1906 in recognition of the great merit of his theoretical and experimental investigation on condition of electricity by gases. Joseph John Thomson was born on December 18, 1856 in Manchester, England. His father Joseph James Thomson, also a J. Thomson, ran a specialist bookshop that had been in his family for 3 generations. His mother came from a family that owned a cotton company. A shy boy, his parents hoped he would become an apprentice engineer with locomotive company. These hopes were dashed with the death of his father when JJ was only 16 years old. The fees for engineering apprenticeship were high and his mother could not afford them. He earned a master's degree in mathematics. One of his students was Ernest Rutherford, and his student Ernest Rutherford put limitation in Thomson's theory. What a proud teacher on his student. In 1911, Rutherford performed a very famous gold foil alpha particle scattering principle. He imposed alpha particle on 100 nanometer thickness of gold, and out of 20,000 incidental alpha particle radiation on the gold foil, only one or two will bounce back. And on the base of that, he stated that protons are not uniformly distributed in atom as in a plum pudding model stated by J.J. Thomson, but it is distributed, it is concentrated into small part which is called nucleus, and electron is moving randomly surrounding the nucleus, and stating that Rutherford has given a planetary model to address the atomic structure as Earth and other planets move surrounding Sun. Much in the same way, electrons are moving surrounding nucleus, and protons are concentrated into the small portion known as nucleus, and electrons are moving in extra nucleus. So that concept has been given by Ernst Rutherford, who was the student of J.J. Thomson, who later succeeded him as Cavendish Professor of Physics. In addition to Thomson himself, 6 of his research assistants, Charles Grover Barkla, Neil Bohr, Max Born, William Henry Bragg, Owen William Richardson, and Charles Thomson Rees Wilson, won Nobel Prize in Physics. What a proud teacher J.J. Thomson, who has 6 assistants got Nobel Prize, and it not limit up to that as well. His own son, his own son also got Nobel Prize. Thomson's son George Paget Thomson won Nobel Prize in 1937 in physics for proving the wave-like properties of electron. So that is the contribution of J.J. Thomson in addressing, in searching the electron negatively charged particle, as well as he has contributed to develop his research colleagues like his student Ernst Rutherford and their colleague Neil Bohr, and many got a Nobel Prize. Now, Ernst Rutherford, as I've said, gives planetary model of the atomic structure, get limitation, and that limitation is given by nobody else, his own colleague, that is Max Born. Max Born stated that planets are big in size and they do not have charge, and therefore we cannot compare the atomic structure with a planetary model, because in atoms particles are such small even we cannot see through naked eye, and therefore these small microscopic particle which are charged in nature, if it will rotate to the atom surrounding, then the concept of this extra nucleus, the rotation of electron having a charge in it, get accelerated, and slowly, gradually it come closer to the nucleus, and then it enter into the nucleus get collapse, and the atom stability cannot be addressed. So that is the limitation of Ernst Rutherford's atomic structure of planetary model bring by Max Born. And then after Neil Bohr has given his own theory, he stated that yes, protons are concentrated into small part of nucleus, but electron is not randomly moving like a planetary system, but they are moving in a stationary orbit surrounding nucleus. And to explain this, he has given the spectra of hydrogen atom, and then after you have already studied the different spectroscopical series given by Freund and all for the hydrogen atom. But Niels Bohr's atomic model is limited to address only hydrogen atom. For multi-electron system, Niels Bohr cannot address his that is the limitation of his atomic model. Or there should be a big break in explaining the atomic structure 1913 to 1926. In between, some study has been done for electromagnetic radiation or black body radiation addressed by Max Planck in 1900. And after studying black body radiation, Max Planck stated that electromagnetic radiation which already have a wave nature should have particle nature. So that was his theoretical research in 1900. Max Planck have given a statement that electromagnetic radiation which already have a wave nature can have a particle nature. Now student, you need to know how wave nature can be established for anything. So wave nature has been established by two scientists, Huygens and Young, and they stated that if anything should have deflection or interference, refraction, diffraction and interference should have a wave nature. So that way wave nature electromagnetic radiation have, but that electromagnetic radiation should have particle nature or not, that is unknown at that time. Max Planck has given his theory in 1900. 2 years later, Albert Einstein, who is very much follower of Max Planck, given his theory based on Planck's statement that electromagnetic radiation should have a wave nature, should have a particle nature as well. So that duality has been explained by giving experimental verification by Albert Einstein in 1902 by giving photoelectric effect, and he earned Nobel Prize for that as well. Albert Einstein has taken a nickel metal surface and he imposed a beam of radiation. That radiation have enough frequency to eject an electron, much like a carom game. Student, you know that when you are in a carom game, when you are going to hit a striker, the striker get kinetic energy. He then collide with an object. He pass on the kinetic energy to the object, and striker stop there and the object start moving. So that is the way the particle nature would be. Wherever particle nature collide with each other, that particle will pass on its kinetic energy to the another body. So much in the same way, when a radiation imposed on a surface of nickel metal, that radiation have enough frequency through which it will collide with electron already have a particle nature. Then only electron can be ejected if the incidental radiation should have a particle nature as well. So when a beam of radiation is imposed on a nickel surface, one of the electron get ejected with a flash, which is known as photoelectric effect. So this experimental verification proves Max Planck's statement of duality of electromagnetic radiation, and for this electromagnetic radiation Planck coined a new word known as photon. So photon is used for electromagnetic radiation to describe its duality, both wave nature as well as particle nature. So after this study in 1902, 22 years later in 1924, one another scientist, de Broglie, has given us another concept, converting the Max Planck statement that if radiation, electromagnetic radiation which already have a wave nature behave like particle, then why not electron, proton, hydrogen atom kind subatomic microscopic particle which already have a particle nature behave like wave. So he has given a duality theory of the wave nature associated with particle like electron, proton, hydrogen atom. If you have studied the autobiography of this de Broglie, you come to know that how much things to learn from his autobiography. He is a history graduate. During Second World War, he is doing job as radio communicator. Then after, he has developed his interest in science and he has done his DSc in physics. So a history graduate done DSc in physics, and then by giving this theoretical research in 1924, he earned a Nobel Prize for himself, giving the duality of this wave nature as well as particle nature of an electron. His this invention has lot of what we can say importance in the science field, because on the base of his invention, electron microscope is invented. This is the application of de Broglie's matter wave on the duality concept of matter wave. Electron microscope is invented, which can increase 2 lakhs pixel higher than the original form of any object, and due to that the diagnosis of microorganism and all microbiology related sciences develops by this research only, given by de Broglie's matter wave concept. This is a theoretical research, and people was so much orthodox that time, they won't accept anything without experimental verification. So in 2 years later, 1926 around, two American scientists, C.J. Division and L.H. Gamma, has given experimental verification to de Broglie's statement. They have taken a crystal surface and they imposed a beam of electron, much in the same way as Albert Einstein has imposed a beam of light on a nickel surface. When they imposed a beam of electron on a crystal surface, they found interference, one of the property to establish wave nature of anything. So on the base of that, they stated that the electron, when imposed on a crystal surface, give interference, means electron should have a wave nature. So experimental verification to de Broglie's statement is given by L.H. Gamma and C.J. Division. And after that, in 1926, another German chemist, Werner Heisenberg, who is also the director of atom bomb committee during the Second World War, has given uncertainty principle and gave a statement that for moving microscopic particle, it is impossible to measure the momentum and velocity simultaneously. That uncertainty principle brings some lot of question in the explanation of atomic structure, and therefore in 1926 Erwin Schrödinger, Finnish physicist, gave a wave equation, and his wave equation gave full information regarding the atomic structure and behavior of electron surrounding nucleus, and based on that, electron configuration has been developed on the three basic rules: above principle, Pauli's exclusion principle, and Hund's multiplicity rule. So that is how atomic structure evolution can be done. So this is the historical background to address the atomic structure. When we meet next time, we're going to have in-depth study of atomic structure given by de Broglie. Thank you for paying attention to this video lecture, and I inspire all of you to ask question, as you know that asking question is a beautiful way to gain knowledge. So please post your queries and question in the chat box on Moodle, or either you can email us, and in our convenient time we'll address all your queries. Till then, goodbye from my side.